Clearly, in intelligence and security informatics, that wouldn't be the case. So you would be concerned with detecting deception and misinformation and so on. It also occurred to me, some of my advisors in graduate school, besides working on probabilistic information retrieval, also developed models for utility theoretic retrieval. So instead of trying to predict the probability that a given document will be relevant for a particular user based on the features of the user, their information needed in the documents, instead you try to predict the utility this document would have for this user and rank according to utility. And I think that could also apply in these kind of situations. So it may not be, maybe it's less important that this document is on this topic as being able to know whether it's misinformation or reliable information. And even if it's misinformation, if you can detect that, it's still useful to know that. It might be have very high utility, in fact. And then getting back to Libicki's original concerns, clearly there's a large role for all of this in software agents in warfare, semantic attacks, information operations, and so on. So a little over a year ago, I was involved with a workshop at the Air Force Research Lab where they were planning a new program, which some of the BAs are just starting to come out for now, for the commander's predictive environment. And we're looking at detection, deception in that area. And more recently, I've started working on a project at Dartmouth our system's called adversarial intent inferencing. I guess the project's called adversarial reasoning. And one of the issues that we're looking at is not just deception at sort of the low level of an individual document or an individual face-to-face communication, whether in text, audio, or video, but how does this all play potentially into a larger, more strategic deception? So you think about things like in World War II when the Allies are trying to conceal from the Germans that D-Day invasion is going to take place at Normandy, and so there are all kinds of elaborate things done to convince the Germans that it was going to take place somewhere else or a different time and so on. So we're interested in this idea of how can we achieve some kind of vertical integration between the low-level deception we may pick up and sort of map that into a more strategic deception that may be going on. And this is just still at sort of the speculative stage. We haven't actually begun doing this sort of work yet. So in one of these programs that I mentioned, there's been this novel intelligence and massive data program. All of the participants in this program were expected to read a book by Richard Hoyer on the psychology of intelligence analysis, where he develops a model called analysis of competing hypotheses, where if you're considering some hypothesis, and you could say maybe this is similar to the scientific method, so you consider all the possible hypotheses, you gather evidence on favor of the different hypotheses, weigh them, and come to your conclusion. Frank Steck at MITRE has developed a variant of this in a sort of prototype software system called analysis of competing hypotheses counter-deception. And with Professor Santos at Dartmouth, we're also developing a system which we intend to apply to some of the same examples that Steck discussed, such as the Battle of Midway during World War II. So Steck, in turn, based his theoretical approach on a number of other earlier investigators. So I mentioned Hoyer, and so other work in deception detection has been done by Whaley and Busby, more in the business sort of literature and sort of financial fraud, accounting fraud areas. Johnson and others have developed models, and in more intelligence work, there's work by R.V. Jones. So they're basically taking some of the theoretical background from all these approaches and implementing them in a computer system for adversarial reasoning and deception detection. And they have a project where they apply this to detecting deception in within the, say, corporate financial filings. But there's a lot of controversy about some of this. So, there was some fairly recent government study of polygraphs, for example, which called into question, just the validity of the whole technique. Or, people talk about detecting deception in video, but, it's unclear how accurate all of these really are. Well, I guess an issue in a lot of, sort of psychology sort of work is, okay, you can produce something in the laboratory with, freshman college students, but does this necessarily carry over into the real world, so to speak? And then again, even if you're able to achieve this deception detection at a lower level, then how do you integrate that with, looking for more strategic sort of deception? So one of the things we hope to do here was MITRE was developing a counterterrorism database which was seeded with a deception scenario. And one of the things we hope to be able to do would be to apply various of these techniques we talked about to see if we could discover the documents in this database that were related to the scenario and then determine where the deception was in the scenario and sort of unravel what was going on. So going back to this commander's predictive environment, we want to be able to, like say in a military setting, improve the understanding of the operational picture, be able to characterize and predict likely future events in the planning and execution process. So this is something to supporting the commander and understanding the impact of decisions today. And in order to do all of this, you can't just assume you can take all of the information that's coming in through your sensor systems or intelligence reports at face value and just fuse the information and act accordingly. You have to actively consider that there's going to be deception and trying to deal with that. So currently, I'm working on a project with Eugene Santos where we're trying to model an adversary using a Bayesian belief network representation where we have nodes representing the goals, axioms, beliefs, and actions, both of, well, basically we're modeling the adversary, so sort of the red group, and we're trying to infer the adversary's intent based on observations, and this intent can include deception. And we're trying to work up an example for this based on the Korean War and the Chinese intervention in the Korean War. And on the one hand, it doesn't seem like necessarily the best example because there was a lot of evidence that the Chinese were going to intervene. They weren't necessarily concealing that. And I think MacArthur just thought it wasn't worth considering, and everybody sort of deferred to his opinion, and the intervention happened. But as we're digging deeper into it, as in all sort of battlefield situations, there's always deception going on. And we think there are more strategic deception in this example that we can work with also. And of course, one reason for looking at the Korean War is it's long enough ago that this is information is more readily available than, say, something more recent. So let's see. I think we're sort of drawing close to the closing time. Maybe I should pause and ask if there are any questions at this point. Yes?
So I think a very good source of information would be looking at poker games.
Yes.
It is
right.
A deception game.
Right. Well, in fact, Whaley, in one of his books he wrote on deception, he does talk a lot about games and